Hi guys, it's Mr. T again, and still at my virtual beach here, and coming to you today talking to you about arithmetic sequences. Okay, and specifically, what are the algebraic ways to define arithmetic sequence? Okay, so let me slide me just a little bit further up here. Let's go on and get started here. All right, so first of all, what is an arithmetic sequence? Well, previously we described that as it's an addition or subtraction. It's a list of numbers with an addition or subtraction pattern. Okay, just for example, okay, just for an example here. See, yeah, that's good. So let's just give a list here. Let's say 2, 4, 6, 8, 10. Okay. So I just take 2 and add 2 more and add 2 more and add 2 more and add 2 more. So that's an addition pattern. Okay. And if I do 4 minus 2, I get 6 minus 4 is 8 minus 6 is 10 minus 8 is. Okay. So that's an arithmetic sequence, and it's a sequence because it has commas. Now, if I put pluses or minuses even, depending on the situation, between those, it becomes a series. Okay, but this is an arithmetic sequence, and we reviewed some notations. Okay, so previously we'd say, since this is the first thing in the list, we're going to call that a sub 1. And then 4 would be the second thing, so that'd be a sub 2. And then a sub 3. And then a sub 4. And then a sub 5. And that's one way we could write that. But another way, in the way this particular book likes to do it, it would use it as f of 1, f of 2, f of 3, and so on. And so those are two ways to use for notation. Means the same thing. So a sub 1 means the first thing in the list. F of 1 means the first thing in the list. F of 3 means the third thing in the list. Okay. And both of those, if you wanted to be generic, would either be f of n, or you would have a sub n. So that's generic. And with all these previous examples, we started with the first thing, second thing, third thing, fourth thing, fifth thing. Okay. But it doesn't always kind of work that way. And the first thing the book does here is give us an example of one that doesn't start with the first thing. And they're talking about steps. Okay. And so we're going to really talk through this example about steps, starting from the bottom and going up, or from the top and going down. Okay. And they said that you're going to go up 7.5 inches because each step is 7.5 inches. Okay. And then if you start on the floor, that's 0, right? And then you put your foot up, and that's step 1. Okay. So you're starting to count really. So you go 1, 2, 3, 4. Well, what's the floor? Well, that's 0. So you're really counting from 0, 1, 2, 3. And that makes a lot of sense when you're talking about steps, right? You don't count the floor as step 1. But we'll do that for fun here in a little bit. But this is our situation, and they're talking about starting. And so B of S would be, if you start from the bottom, you're going to go up 7.5 inches, 14 steps, and the total is going to be 105 inches. Okay. And then if you start at the top, that's T of S. That means you start at 105 inches and go down by 7.5 inches. So that's the scenario we're setting up on. Okay. So this is not just like a list of numbers where you're starting with the first one. We're talking about a set of steps, which it only makes sense. The floor is step 0. And then the first one you put up your foot on is step 1. Okay. And that just kind of makes sense. And so that's why they picked this to begin with. Okay. And so they got you a little picture of some steps there. Okay. Let's jump here to our next page. All right. So they got this thing set up here. This showing here. So starting at the bottom, steps. So at step 0, which is also known as the floor, right? We call this the floor, right? The floor. So that's the floor. And it is step 0, and it's 0 inches. It's inches, right? inches off the ground. Then after you jump on step 1, okay, now you're going to be 7.5 inches off the ground because you're going to take 0 plus 7.5. Okay, and then what happened here? Okay, the 0's the same, the 7.5 is the same, but this times 2. Oh, because you've done 2 steps, right? So that's where the 2 is coming from. So what do you think is going to happen next? Well, we're going to do 0 plus 3 times 7.5. And then we're going to do 0 plus 4 times 7.5. Okay, and then whatever those numbers are. Well, there's 22.5. Okay, and I guess I can then, and that'd be 30. Yeah, so you get, there's your 30. And so you could continue that on. And there's actually like a 1 sitting right here too, isn't it? Okay. And so what that we're doing here, this is called an explicit process. Okay, this is an explicit process where you're using an equation to get a specific spot. So now that I figured out this deal, I could just put any number I want to. So if I wanted how high off the ground you're going to be for step 8, I don't have to go to step 7, do I? I could just put an 8 right here where that 4 is, and that would get me how high step 8 is off the floor. I don't have to go through all the steps. I can use just the equation to find the answer. That's what's called an explicit process, okay? Explicit process, okay? So this whole thing is just an explicit process. And so since we're here, what they want us to do is write a rule. This is a more of a generic kind of an idea. So what's staying the same? Well, the zeros stay the same. And then we're going to put an in because that's the thing that changed. So you put a variable. And then we said times 7.5. And so now that's what's called a rule. This is a generic thing that includes a variable. Because if I put something in for everything, it's no longer a rule, because a rule is something that's an equation. Remember we talked about a model is an equation, a function, equation, and a formula is an equation. A rule is an equation. It's something that's generic enough that you can use for different, put in different things for that variable. And so this is a explicit rule when you start at the bottom of the steps. Okay. Then here we go. But here we are. We said 105. So this is a top floor, right? So this is top floor. So when you start at the top floor, and we're going to count the top floor as what? Step 0, because you're at the top coming down. And so now we're at 105, and now we're coming down, right? 1 times 7.5. And then we still got 105 minus 2 times 7.5. And then 105 minus 3 times 7.5. Okay? And then that would get you to continue some answers and continue coming down. So it's a very similar thing, just coming from the top, and you're subtracting because you're coming down instead of going up. And so that generic rule for T of S would be, okay, the T of S would end up being 105, 105, right, minus n times 7.5. And so all you have to do is tell me which step you're on, and I can tell you how far off the ground you are. Easy enough. Okay, I don't have to know which step the previous was or anything like that. I can go straight to one thing. That's explicit process. Okay, gives you one equation, gives you one pieces of information. I don't have to know anything else. Go straight there to my answer. Okay, now I can use it over and over again to get more information, but it gives me one piece of information explicitly, specifically, one piece. All right, so that's an explicit process. Now at the bottom of the page, okay, and so that's what that looks like filled out there. Whoops, oh, messed up here. Okay, let's look at the bottom of this page here. what's going on here? Well, when you fill this out, that's easy enough. We can do this. We said this was like, you're going to the first step, the floor, then the first step, the second step, third step, fourth step, fifth step, sixth step, 7, 8, 9, 10, 11, 12, 13, and 14. So if you let the floor be 0, and then you're going to slide your way up to 14 steps. Okay, and so on the floor, you're going to be how far off the ground? 0 inches, right? 0 inches. And then at step 1, 7.5. At step 2, it's 15. At step 3, you're going to be what again? We said that was 22.5. And then at step 0, 1, 2, 3, 4, we said that was 30. And then step 5, that's going to be 37.5. And what you're doing is you keep on adding 7.5. Now, is there some way I can just jump straight over here to this box right here? Well, if we're adding 7.5 every time, I can't figure that out, can I? Okay, because I have to know the previous thing to know what's going to go in this box. Okay, so by adding 7.5 here, so plus 7.5 plus 7.5 plus 7.5. Okay, that makes this a recursive process. Okay, because you have to know the previous term to get the next term. So you're having to go backwards, right? Recursive. You have to go back over to the previous thing and do something to it to get where you're at now. Okay, so to get this box, I have to go back to the previous box and then add 7.5 to it. So I always have to know something previous. That's the re part of recursive. All right, so that's a recursive process. You can't just jump in the middle of something. You got to know the stuff before or after it won. Okay, so now let's jump over here to whoops, 1, 2's too many. Okay, so what we're going to do is where this, and then if you plot those points, I apologize, jumped ahead of myself. And so here's the chart that you would have. You 0, 0, 1, 7.5, 2, 15, 3, 22.5, and then you continue going through that deal. We don't connect the dots though. That's very weird, right? But this is a discrete process, which means it's very concrete. You know what happens when you go to 1.5 steps? You fall on your face, and we don't want that, right? So this isn't one of those things that you would connect the dots. And look about this. Let's go back to this very first thing. Is what's between the 2 and the 4? A comma. So we don't connect them. They're individual things, right? They're individual slots in our process, okay? So we don't connect them. They're just going to be the dots. And that it seems kind of weird because you usually plot your points and then connect the dot, right? But this is one case we don't connect the dots because you got to remember, if you jump, what happens when you do half of a step? You fall on your face. We don't want that to happen. So let's not do that, okay? All right, so what we're going to do here is I'm going to take this scenario that we've got going here, and I'm going to work on finding a generic rule using the explicit formula and a recursive formula, okay? And so we're going to start off just like it does here, and then we're going to come back and pretend something a little bit different so we see how that changes, okay? So an explicit. So I'm going to start off by writing the rule, okay, the generic formula here, and that's A sub n equals A sub 1 plus n minus 1 times D, okay? So, well, I'm going to come back here and I'm going to remove the 1 because what we're going to say here is this is the beginning spot. Whatever it is, the beginning spot. So for our case, what is this? So we're going to say that this right here, that's A. That's A. Okay? That's where we're beginning. We're starting with 0 inches off the ground. Okay? So that's going on. Now, what is D equal? What does D equal? Well, what is 15 minus 7.5? 15, right? I mean, 7.5, right? So what does D equal? D is going to equal 7.5 every time. And to do either one of these, that's what you need. You need where you start and what the pattern is. Where you start and what the pattern is. No matter whether you're doing explicit or recursive, you need to know where are we starting and what your pattern is. And that's the same thing for arithmetic or geometric, because geometric is just, instead of adding 7.5, you would be multiplying by 7.5, okay, or dividing by 7.5. But it's still where you start and what your pattern is. Okay, so those are the two things you need, okay, because you're going to leave n by itself. Okay, so here we go. So for our deal here, we know that A is 0, D is 7.5, and that's going to be true for everything here. Okay, so let's write down my formula. I always like to write down my formula. So we got A sub n equals A plus n minus 1, and then the D. So we got 7.5 here, and then we got 0 there. Okay. Oh, there's one small problem. This starts at 0. So when it comes to an explicit rule, we're not going to do n minus 1 if we start at 0. Okay? That's going to be n minus 0, which is really just plain n, right? So when you start with 0, we don't use the 1. When you start with 1 at the, with the first spot, with the first, with n being 1, then you use the 1. That's kind of weird for the moment, okay? Let's do some of these examples and it should probably catch up on you, okay? So here's the deal. This is the generic formula that we use for arithmetic sequences, period. Okay, but what I'm saying here is if you're going to start at 0, drop the 1. Okay, and when you start at 1, keep the 1. So 1, keep the 1. If you don't start at 1, drop the 1. Okay, but because n minus 0, it's just nothing. All right, so this is probably good, but we need to simplify this down. So 0 plus that stuff is going to have no effect. Okay, so this is going to end up being A sub n equals C. Well, it's just going to be 7.5 n. Okay, or you could say this is f of n equals 7.5 n. Means exactly the same thing. Okay, why are we using n instead of s? Well, it's just a more generic way of saying. So instead of using s for step, we're just using n. It's kind of like normally in algebra we use x's all the time. As a matter of fact, when we use other letters, sometimes we end up going back and reverting back to x because you're just used to using x so much. That's the same thing when it comes to sequences and series. We normally use n. And so I revert back to using n, even if it specifically is s for steps this round. So we're just saying with the generic, it's kind of a normal deal, okay? No big deal. So this is what happens when you start at 0 for explicit, okay? Whew. Now, what happens when you start at, well, all that should have been in green, shouldn't it? Oh, well. Let's keep rolling. Let's just say we'll do this one in green. Let's do this in purple. All right. So what happens when you start at 1? Well, let's write down our formula. And then plus n minus 1. Okay. Because the same generic formula applies to both of them, right? Except when you start at 0, we drop the 1. Okay, so this time, since we start at 1, we keep the 1. So what we're basically doing here is we're pretending, instead of having the floor be step 0, we're pretending that this is step 1. That makes this what? Step 2. then this will be step 3, 4, and that's not going to be 14. It's going to be 15. So if we started counting at 1 instead of 0, we're going to end up at 15 instead. And that's going to have an effect here in just a little bit. So we don't normally do that. It's kind of silly, but it's just work with me here. We're pretending like the floor is step 1, okay? And instead of starting at 0. And just to show you what difference it makes, okay? So does this step look exactly like that up there? Yes, it does, except for what? If you start at 0, there's a 0, and if you start at 1, there's a 1. Everything else is going to be identical. So you're still going to have your 0 here. You're still going to have your 7.5 here. Now, because the 1's there, now we're going to have to distribute the 7.5. So that part's going to be a little different. So A sub n, and so that just disappears. And so 7.5 times n is 7.5 n, and then times -1 would be negative 7.5. Okay, so there's that. So let's check out our work, okay? Let's check out our work. Let's plug in some numbers. So let's go back up here. So if I plug in a 0, I better get a 0 when I start at 0. So what happens here? 0 times that gives me 0. What happens if I plug in a 1? I better get 7.5. 1, yeah, that gives me 7.5. So that seems to be working just fine. So when I start at 0, I'm using this list, and that's working just fine. Now, let's check some numbers if we start at 1. Okay, so instead of plugging in a 0, we're going to plug in a 1, and that should give me 0 out. So if I plug in a 1 here, that's going to subtract, gives me 0. Okay, if I plug in a 2, see that 2 should give me 7.5. So 2 times 7.5 is 15 minus 7.5 back to 7.5. It's working. So plugging in numbers helps you check your formula. So this is a explicit rule when you start at 0. This second one here is an explicit rule when you start at 1. Let's go ahead and get a little highlight with that. So we'll highlight this one in green, because that goes with that. And then we'll highlight this one down here in blue. All right, because that goes with starting with 1. All right, let's move me a little bit over here out of the way. Now we're going to do a recursive process with this next piece. Okay, and hopefully beforehand I tried to get everybody to understand when you see n minus 1, I don't want you to think number minus 1. While that is a true thing, what I really want you to be thinking here is that it's previous term, previous term. Okay, so with the recursive process, you always take the previous term and then you do something to it. So you have to start with what are you starting with? Okay, so this one starts at 0, so you have to give, so they're going to say f of 0, okay, so we're back over to here, equals 0. And this is given information, okay? How do I know that? It's given. Or they give you stuff that you can figure it out, okay? So they either tell you point blank, like I just did, or they give you something that, like this table here, that you can figure it out for yourself, okay? Okay, now the next thing we're going to do for our recursive rule is we're going to say f of n, and it's not really an equation per se, it's more like instructions on how to do something, almost. So yes, it is an equation, but it feels more like instructions on what you're supposed to do, okay? So you're going to say f of n minus 1, and every time we see n minus 1, what do we think first? Previous term. All right. So previous term, and what are we going to do to the previous term? We're going to add 7.5 to it. Okay. And there's one more little piece to that puzzle, but we're going to leave that alone for the moment. Okay. So how does this work? Well, they gave us the first thing, which is 0, 0. Then it says, now, if I want to find the next term, I'm going to go to the previous term, which is 0, and add 7.5 to it. Okay? So if I want f of 2, I go to the previous term and add 7.5 to it. Well, if I want f of 3, what do? I go to the previous term and add 7.5 to it. So that's what's going on there. And you can actually plug in some numbers, and that's how that's going to work, okay? So literally, what happens if I plug a 2 in? So I get, just for grins and giggles, I'll go f of 2. Well, what is that? That's f of 2 minus 1 plus 7.5, which is f of 1 plus 7.5. And what does that equal? What's f of 1 equal? 7.5. So 7.5 plus 7.5, and there's my 15. So f of 2 is 15. Okay? And so for some people, that was like, what? And if that confused you too much, don't worry about it too much. What I really need you to remember is what? If I want f of 2, I go to the previous term and add 7.5. That's the thing you want to remember the most, okay? That's the deal. Now, what happens here is that you got to add one more piece of information. We got to say, well, if we're starting at 0, then we're going to pick up at 1 and keep rolling till we get to 14. Okay? So if they start at 0, that means this thing starts at 1. If this starts at 5, then that makes this start at 6, the next thing, whatever it is. But it's usually f of 0, and that's a 1. And then down here, it'll say f of 1, and then that'll be a 2. Okay, we'll make the adjustment for that. Okay, woo. So explicit process using this formula. If you start at 0, drop the 1. Pretty much everything else is straightforward. Here, it looks kind of weird, but the process isn't all that hard. They give you your starting line, and then you start adding 7.5. Add 7.5, add 7.5. Well, how long do you do it? Till you get to the n equals 14, and then you're done, okay? Because they said so. It's right here. All right, so now let's switch up, and let's look at starts at 1. Okay, so we're not going to pay attention to these numbers. We're going to be paying attention to the little purple numbers. I call it purple anyway. I'm sure somebody will tell me it's a different color. But that's the idea for me anyway. So, okay, again, you're going to have to be told where to start. And so in this case, f of 1 is still going to be 0. Okay, we might count the floor as step 1, but it's still 0 inches off the ground, right? Okay, so, and again, that is given information. You're either just straight out told, or you got something to figure it out with, okay? So that's your starting point. You're starting, whether you start at 0 or you start at 1, okay? What about this next line? Is there anything I should change on this second line because we're starting at 1? Well, with the explicit rule, we changed it from n minus 0 to n minus 1, didn't we? But with recursive rule, there's no changes. It's identical. There are absolutely 0 changes to this next step. Because we're still saying to find f of n, we're going to take the previous term, and then we're going to add 7.5 to it. There are 0 changes to that line. What's the only thing that really changed is where are you starting from? Are you starting from 0 or you're starting at 1? But you're still adding 7.5 no matter what. Okay, well, if we start at 1, what's the next thing? 2. Okay, less than it. Oops. Yeah. Okay, so we got 2. Hello. My purple there. 2 less than or equal to n, less than or equal to, it's not 14 anymore. Because if you call the floor step 1, that means the top thing is going to be not 14 anymore. It's going to be 15. Okay, and this right here is where people get bogged down on. It's a minor issue, guys. Okay, here's what you start with, and this is what you do to it. Here's what you start with, here's what you do to it. That's all recursive is. Okay, so recursive is pretty easy. Weird the way they write it. The strength of recursive is it's easy to work out because you just keep adding or you keep multiplying. It's geometric. Okay, the problem here is if I want the 100th term, I got to do 99 first if I don't know, right? The cool thing about explicit, as long as I know what A and D are, I can figure out the 100th term and skip all the rest of them. That's cool thing about explicit. It goes jumps to just whatever you're interested in. Recursive, you have to walk through to get where you're going. Okay, so that's the explicit and recursive. So let's do a couple more examples here. And here I am stuck in the middle. This on the next page is a lot of what we've already talked about. It's typed up nice and pretty. And this is doing from the bottom of the steps. And then they do the same thing again from the top of the steps. So that could be useful. If you really want to examine that, you can pause this and take a closer look. All right, so let's do a few of these guys. So what is it that we need to come up with an explicit or recursive rule? Doesn't matter whether it's arithmetic or geometric. The same thing as always is, where do you start and what's the pattern? Okay, so this is what we need right here. So we need to know that this is A. Okay, that is A. And we're going to start what? We're going to start counting at 0. So this is A sub 0. All right. The next thing we need, what is the next thing we need? We need to know what D is, right? What is D? Well, D is going to be equal to 5 minus 2, because that's how you figure that out, right? This minus the previous, which is 3. Well, let's check it out. Let's do 8 minus 5, still 3. 11 minus 8, still 3. Okay, so what we have here, that's called a common difference. And what are the two things you need? You need to know where you start and what you're going to do. What is the pattern? So we're adding 3. Okay, so we're going to start with counting at 0 and the A equals 2, and we're going to say that we're going to go by adding 3s. Sorry. So let me jump over here where it's got some of it filled in. So here's the explicit, here's recursive, it's filled in. So here's my explicit formula here, and let's start plugging in some information. So my A is 2, my D we said was what? Peeking behind here? 3, okay, put me over here. 3, then we just kind of clean this up. So that's going to give me 2 plus 3n minus 3. 2 minus 3 gives me negative 1. So A sub n equals 3n minus 1. Now, I know some folks are going like, oh, well, that means you just put the D there and you put something right here and you can figure out something. Don't do that. Just use your formula. Just use the formula and work it through, okay? Less to remember, I'll just use the same formula over and over again. And sometimes it's a little overkill, but it's better that than to have to remember a whole bunch of more things. I like remembering less things, okay? And if they work every time, I'm all happy, okay? So this is explicit. And don't forget, another way we could say this, instead of A sub n, we could say that is F of n, right? And that's what they use up here. So that is my explicit rule, okay? My explicit rule, E rule, okay? Now let's go over to recursive. Now where are we starting? Where are we starting with recursive? We're starting at 0. And what does that give us? 2. Okay? Starting at 0, that gives us 2. So to find anything we want to, we go with the previous term plus 3. Okay? Previous term plus 3. So if I want f of 1, I go to the previous term plus 3. If I want f of 2, I go to the previous term plus 3. Okay, so if we start at 0, where do we want to pick up from there? 1. And we're going to go all the way up to 5. Okay, so there's one of those. Okay, let's look at this guy. Get me out of the way. Again, where do we start and what's the pattern? So here's where we start, right? We're going to start at 1. We're going to start counting. Start counting. Okay, start counting at 1, and 29 is going to be n. I said n. That's a. Goodness gracious. That's n. This is a, right? And this is going to be a sub 1 specifically. All right. Now, what is my d? So we said we got to know where we start and what the pattern is. So my d in this case, because this is arithmetic, and if I didn't know it, I'd just have to check. Okay. So I do 25 minus 29. That gives me negative 4. All right. Well, let's check to see. Then we can do what? 21 minus 25, still negative 4. Okay. 17 minus 21, still negative 4. Okay. That's my common difference. So D equals negative 4, and my A sub 1 is 29. So that's where you start and what the pattern is. Okay. So here we go. This is explicit on the left, recursive on the right. And I'll put myself over here where you can see what's going on. All right, where do we start at? 29. What's our pattern? Negative 4. And it's n minus 1 because we're starting at 1. If that was at 0, we would drop the 1 or put a 0 there. It would be the same thing. Okay, so this is going to be 29. Then negative 4 times n is negative 4n. And then negative 4 times negative 1 is positive 4. Okay, let's combine some like terms here. So 29 plus 4 is going to give me 33 minus 4n. Or we could say that's negative 4n plus 33. Either way works fine. Okay, all right. So now let's try recursive. Now where are we getting this thing started again? Starting at 1. So f of 1 equals 29. You got to give them the starting line. Okay, because without the starting line, recursive is useless. Okay, so if you tell me, hey, what's the third term, but you don't tell me the second term, I can't tell you. You know, you can tell me, oh, we're just doing d equals negative 4. Well, that's great. Negative 4 of what? I got to know the previous term. And so that is what goes on here, n minus 1. And so recursive, we always use the n minus 1. Recursive, we do what? Always the n minus 1, because you always have to have the previous term. And then put our negative 4 in here for our d. Okay, now another way we could write that is instead of the f of n notation, the a sub n, so the f of n minus 1 is going to be a to the n minus 1, then that'd be minus 4 there. Same idea, okay? Just a different way of writing the idea. And say, so if we're going to start at 1, we're going to pick up at 2, and we're going to keep going till we reach 6, okay? What if there's just dots instead of 6? Well, we don't put the 6. We just go numbers greater than 2 and just leave it at that. All right, there's a couple more, okay, examples. I got 2 more here that I'm going to kind of refresh our memory about how to do that. Now, again, what do you need? But regardless of explicit or recursive, you got to know where you start and what the pattern is. Okay, so just 2 more real quickly here. Start counting right here. And start counting right there at 0, and A is negative 7. We're going to start counting right here at 1, and our A is going to be 11. So then what is D going to be? Well, D is equals to, ooh, look at all those crazy negatives. Well, you could say, well, that's negative 2 minus negative 7. Well, that's really plus, so that gives me what, 3? Is that 3? No, that's 5. That's 5. Almost. And then you got 3 minus negative 2. That's definitely 5. And then you got 8 minus 3 equals 5. Just a little hint. Why don't you just start at 8 minus 3 and 13 minus 8 and skip all the negative stuff? Because if it's a common difference, you can start anywhere because it's always going to be the same. Okay? And so you're going to plug in 5 for your D, -7 for the A. Okay? And for explicit, you're going to drop the -1. But for recursive, no big deal. We leave our n minus 1. And then over here, what's our D for this guy? Well, I just got finished telling you, skip around the negatives. Oh, here we go. We can still do this. So it's 5 minus 11. Okay, so it gives me -6. And that's what the other ones will be too. All right, so that is explicit series sequences. Sorry about that. That's arithmetic sequences and explicit rules and recursive rules. Okay, and of the two, the explicit is way more cool and powerful and more important for us. But recursive is something that comes up kind of in tandem, kind of drags along with this information. So we got to still be at least a little bit familiar with that as well. As always, hope that it's helpful and good luck.